In this video, we're going to learn how to set up a system of three equations with three unknowns in order to solve a real-life word problem. In this situation, we have a swim meet where main east dominated in the individual events with 24 individual event placers scoring a total of 56 points. A first place finish scores 5 points, a second place finish scores 3 points, and a third place finish scores 1 point. Having as many third place finishers as first and second place finishers combined really shows the team's depth. The question is, how many finishers were there in each place? So just like when we solved word problems that involved two equations with two unknowns, first thing you probably need to consider here are what are the unknowns, and a good place to find that is what is the question asking in the problem. And in this case, we're asking how many finishers were there in each place. That's our key, that we're really trying to find the following unknowns or the following variables. Let's let x be the number of first place finishers and let me see if I can zoom in here and try to make this a little bit nicer. And let's let y equal the number of, let's just write second place finishers, and let's let z equal the number of third place finishers. Once you have that, you are armed with the ability to try to create some equations now. So really we're trying to find three different equations that involve x, y, and z. So let's see if we can get some information from the original problem. We do know that we had 24 individual event placers in all. So the total number of first place finishers added to the second place finishers added to the third place finishers would be 24 total athletes. So I know that one particular equation I could set up would just be if I add x to y to z, I am going to get a total of 24 total athletes. That's one equation. I also know that these placers scored a total of 56 points. Maybe I can set up an equation that involves the total points earned. I do know that for every first place finish, I scored 5 points. So I can do 5 times the number of first place finishers to get the total number of points that those first place finishers earned, and I can add to that 3 times the number of athletes who finished second place, and I can add to that how many points did third place earn? Looks like just 1 point over there. So I can do 1 times z, or could I just written plus z, to get the total points earned, which was 56. So far, so good. I have two equations, but that's not good enough if I have three variables. In order to solve this system, I would need a third equation. The good news is that last sentence it provides some insight into what we can write here. I have having as many third place finishers as first and second place finishers combined really shows the team's depth. What they're really telling you here is they had as many third place finishers, which were z's. So z equals the sum of first and second place combined together. So if I added the first place finishers to the second place finishers, I would have the third place finishers. So these are my three equations. One thing that I would do before we begin solving this system is arrange this so it looks somewhat like the equations that we set up in class earlier in the week. So what I might do is, if I can scroll down, which I can't, let me see. So what I'm going to do now is go to a new screen, and I'm going to rewrite those three equations how we might have written them in a normal problem that wasn't maybe a word problem. Remember, the first equation was just x plus y plus z was a total of 50, or excuse me, a total of 24 athletes, and was a total of 24 athletes. And I know that 5 times the number of first place finishers plus 3 times the number of second place finishers plus 1 times the number of third place finisher gave me my total points earned on the meet, which was 56. Now recall that third equation was that the third place finishers equaled the sum of the first and the second place finishers. I'm going to write this so it looks similar to the other two equations by simply subtracting x and subtracting y from both sides of the equation, and I end up with negative x minus y plus z equals 0 if I were to rewrite that. So let's rewrite that down here as minus x minus y plus z equals 0. Here are my 3 equations. So let me erase this out of the way. We don't need that anymore. And remember when we were talking in class to stay organized, we called the top equation E, if I can get this to work, and I'm having a hard time here. Let's call this E1, this guy E2, this guy E3. So from here, our first step is to pick a variable to eliminate in 2 different ways. So, geez, a lot of options here. I'm kind of liking x because I know I can add E1 to E3 without doing anything, and I can eliminate an x. I can also multiply E3 by 5 to eliminate x with E2. So let's do that. Let's eliminate x by doing the following routine. Let's do equation 1 plus equation 3. That's one way. Another way of doing this would be to do 5 times equation 3 and add that to equation 2. That should also do the trick of eliminating x. Let's see if we can carry out this first step underneath. If I do x plus y plus z equal to 24, and right underneath it negative x minus y plus z equals 0, and solve that, we're going to get the x's to cancel, and for free, without even intending it, we get the y's to drop, and z plus z is 2 times z, and I get that to equal 24. Good news is I can figure out what z is right now if I divide by 2, so I'm going to go ahead and do that, giving me the fact that, oops, let's erase that mark, I don't want that, giving me z equals to 12. I'm going to put that over here in a box so remember what I've achieved there. I got z equals 12. Let's set up this guy right now. If I do 5 times equation 3, would you agree I'm going to get negative 5x and a negative 5y, let's make that into an x there, and then plus 5z equals, now if I multiply the 0 to 5, I still get 0 there. So I didn't forget to multiply 0 to 5, I just have a 0. If I add that to equation 2, I'm going to have 5x plus 3y plus a z equals to 56. If we solve this, or add them up rather, these are going to cancel as designed. I'm going to have negative 5 plus 3 to get negative 2 times y, and then I'm going to get 5z plus 1z to get positive 6z equals to 0 plus 56, I get 56. So what I'm going to do is take this equation along with the fact that I know z equals 12, and I can figure out y. This is a little unorthodox from what we've seen in class, but it's actually going to be pretty helpful. Let's see if we can do this on the next page. So to finish this off, remember we have negative, oops, let's get rid of that. Let's go back here. If I have negative 2y plus 6z equal to 56, and remember I knew also that z was equal to 12. why not substitute that 12 in for z and solve this so I can find y? I know 2 times y plus 6 times what I know now is the z value to be 12 should be equal to 56. So that's going to become negative 2y plus 6 times 12 is going to be 60 plus 6 times 2, that's going to be what, 72 equal to 56. I can subtract 72 from both sides, giving me a negative 2 times y equal to a negative, let's see, that's going to be a negative 16. And if I divide by negative 2, I will get y equals positive 8. So right now I have the z is 12, y is 8. All I need now is x, which remember was my number of first place finishers. If you recall, I have an equation where I can find x here, here, here. Actually, any one of these equations, E1, E2, or E3, are going to work just fine for me. Actually, if you want to look at these equations too, we can use any one of those to find x. Why not just use equation 1 to find x? So that meant if I add, let's go back here, remember it was x plus y plus z equal to 24, that was equation 1. I don't know what x is, but I just figured out y is 8, and I know z was 12, and that should be equal to 24. That means x plus 20 equals to 24. If I subtract 20, I know x has to be 4. So to answer the question, it appears that I have 4 first place finishers and I had 8 second place finishers, and then I had 12 third, 12 third place finishers. So this would be the answer. What I would do before I turn this in though is just double check everything kind of makes sense. If I add all these up, I want to make sure I get 24. 4 plus 8 plus 12 is 24 total athletes. Remember that second equation, this guy here, if I were to do 5 times the number of first place finishers, which let's just do it for giggles, if I do 5 times the number of first place finishers, 4, and I add that to 3 times the number of second place finishers, 8, whoopsie, 8, and I add the number of third place finishers, 12, I should get 56. 5 times 4 is going to be 20. 3 times 8 is going to be 24. Plus 12, we should get 56. And I think if you add that, 20 plus 24 is 44. And another 12, that's 56. So we're looking good. And I can do negative x minus y plus z equals 0. Or, remember, that came from just the number of third place finishers, z, which we now know is 12, should be equal to the sum of the first place plus the 8th place finishers. Guess what? 12 equals 12. I've just checked it in all 3 equations and we are golden. I am very confident that this is the correct answer.